Now, in the next section of this unit, we are supposed to discuss in brief about the recommender systems. Right? So, shall I proceed?
Yes, ma'am.
Fine. So, in our everyday life, actually, we come across one or other kind of recommendations. What I mean by that, say for example, you might be curious of knowing how does YouTube know what videos you should watch or you will watch. How does YouTube know what videos you will watch? Or how does Google always seem to know what news you will read? Or does Amazon suggest us what to buy? Or how does Facebook suggest whom to be friends with? So always Facebook is suggesting us, right, for new friends, right? Even how does Netflix tell the movies to watch? So you might have observed that YouTube always suggests us the videos to watch. The Google always tells us which news we should read. Or Amazon, while buying something, Amazon suggests us what to buy. Or the Facebook suggests us the probable friends, right? Or the Netflix suggests us which movies to watch. So actually, how it happens, how these different applications are suggesting us what to see, what to buy, what to read, and so on. So the answer to all these questions is the recommender systems. So all these applications are actually making use of the recommender systems, right? And these recommender systems are actually suggesting us lots of things. Okay, so what are recommender systems? The recommender systems are the class of techniques and algorithms which are able to suggest the relevant items to the users. And repeat, recommender systems are the class of techniques and algorithms which are able to suggest the relevant items to the users. Ideally, the suggested items are as relevant to the user as possible so that the user can engage with the suggested items. For example, the suggested YouTube videos or the suggested news articles or the suggested online products to buy and so on. So in fact, the items are ranked according to their relevancy. And the most relevant items are being shown or suggested to the users. So, the relevancy that we are talking about, the relevancy is something that the recommender system must determine. So, recommender systems determine the relevancy of the items with respect to the users, right? And finding out the relevant products or the relevant items is typically based on some historical data. Right? Say for example, if you have recently watched the YouTube video on, say, regression, then you might have observed that if you have recently watched the video on regression, then the YouTube is going to suggest you lots of videos related to regression, having the similar title or the similar themes. You might have observed this. Have you observed such kind of suggestions on YouTube? Yes
Yes,
or
ma'am.
no? So always, whatever we have watched on YouTube, you will get the similar kinds of suggestions. If we are buying on Amazon, then the similar kinds of products will be popped up so that we can go and we can see and we can buy those products. So how it happens? Actually, the recommender systems are working behind such kinds of suggestions. And the recommender systems are the algorithms. Those are actually suggesting us based the relevant items based on the historical data of the user or based on the behavior of the user. Right? Now, these recommender systems are typically classified in two important categories. So, we may have the content-based recommender system or we may have the collaborative filtering. Further, the collaborative filtering algorithms are being classified as model-based collaborative filtering and memory-based collaborative filtering. We in fact are not going into the details of all those algorithms, but I'll be giving you some glimpses of these algorithms and the recommender systems. Right? So, the first categorization or first two types of the recommender systems are the content-based recommender system and the collaborative filtering recommender system. So, what is content-based filtering or content-based algorithms, recommender systems? So, in content-based filtering, we are concerned about a specific user. Right? Now, what happens in the content-based recommender system is, if I am the user and suppose if I am reading some kinds of articles every day, then that historical data, this is my historical data, right? So if I am the user and I used to read some kinds of articles every day, then what kinds of articles or which are the articles those are read by me is being remembered, is being stored somewhere in the system, and that is the historical data with respect to this user. Now, in content-based filtering, what happens is, depending upon the choice of the articles read by that particular user, the similar kinds of articles are being filtered out from the huge database, and these articles are recommended to you. Right? So, I am typically using some product, I am typically using some kind of reading some kinds of articles. So, the system actually keeps track of my reads, or the system keeps track of whatever I do. Right? And the similar kinds of articles or the similar kinds of products are being recommended to me. So this is the content-based filtering. So whatever is the content, whatever kind of articles I am reading, the similar kinds of content, the similar kind of articles are being recommended to me based on my historical data. Right? So, the content-based filtering algorithms recommend the products which are similar to the ones that a user has liked in the past, right? Usually while surfing or while browsing, what we do, we come across some products and we may like or we may dislike the products, right? Or the articles or the news or whatever it may be. So what we do usually is we click on the like symbol or dislike symbol, right? And we move forward, right? Or in some other cases, we may rate the article with the rating associated 1 star, 2 star, 5 star and so on. So we provide some kind of a rating to the contents those we have came across while surfing or browsing, right? So these activities are being recorded as the historical data, and based on that data actually my system recommends the products those are similar to the ones that a user has liked or rated in the past. Correct? So this is how the content-based filtering algorithms work. Now, the next category of the algorithms under recommender systems is the collaborative filtering. So what this collaborative filtering is? In content-based filtering, we are concerned with individual user. But in collaborative filtering, what happens is we are concerned with n number of users, and the collaborative efforts are being made while predicting something or while recommending something. What does this mean? On the screen right now, you are watching one figure. So let me illustrate what we have in this figure. We are having few users, right? And we are having few items, correct? So we are having the items like an image, a book, a video and a video game. So these are the items, and the users are liking or disliking. The users are rating those items, correct? So based on the individual users historical data, the likes, dislikes or the ratings, the system tries to predict how the user would rate a new item which they have not yet rated. Meaning, see for example, these users have rated few of the items, but this particular user has not rated this item. This is the movie item. So we are going to predict how this particular user, the last user, will rate the movie, because this user has not rated this movie. So how that user is going to rate that particular movie? Correct? That is the question. And the answer to this question, what would be the rating provided by the user to that movie, is based on the ratings or likes and dislikes by the other users. Right? So this user has disliked that particular movie. Right? So how this is being rated, how this particular movie is being rated? So this prediction is being done by the responses by this user and also the other user for these particular items. So a technique that can filter out items that a user might like on the basis of reactions by the similar kinds of users who already have interacted or who have already been rated, who have rated already for these products. So similar kinds of users. So whatever are the reactions, whatever are the ratings, those are being provided by the similar kinds of users to these products. Those are also being considered in collaborative filtering. So in collaborative filtering, the recommendation is not only based upon the historical data of individual user under consideration, but in collaborative filtering, the recommendation is being done by the similar kinds of users and the historical data of the similar kinds of users for these products or these items. Right? So that is the basic difference between content-based filtering and the collaborative filtering. Is that clear? Yes?
Yes, ma'am.
Shall I proceed?
Yes, ma'am.
Fine. So now let us focus upon the content-based filtering. Okay? So as I stated, this content-based filtering actually considers the historical data of the individual user. Right? So these systems recommend products which are similar to the ones that a user has liked in the past. So if I have liked some articles in the past, then based on that historical data, the similar articles are being found and these are being recommended to me. Right? So this is how such kinds of content-based filtering methods work. One more example I would like to quote here. If a person has liked the movie, say Inception, if a person has liked the movie, say Inception, for example, then this content-based filtering algorithm will recommend the movies that fall under the same genre, right? That of the Inception. Okay, but we having a question how actually the algorithm understands which genre to pick and they recommend the movies from. So which category of the movies are might be liked by that particular user. So how the algorithm understands this? To answer this question, let us go through the detailed procedure. Right? So let us consider the example of Netflix. So Netflix is always recommending the movies. Okay. How actually Netflix works to recommend the movies to the users? If Netflix is using content-based filtering, then it is simply preparing two vectors, profile vector and the item vector. So what is profile vector? Profile vector is related to the user. So all the information related to each user, all the information related to each user is stored in a vector form, and that vector is known as the profile vector. So what kind of information is actually been stored? This profile vector contains the past behavior of the user. That means the movies, those are liked or disliked by the user, and the ratings, those are given by the user to the various movies. That kind of a data is being collected in profile vector. So this profile vector represents a user. Right? Now, another kind of vector is prepared, and that is an item vector. So what kind of information we are storing in this item vector? All the information that is related to movies. Right? So in Netflix, actually users are being given the recommendations about the movies. right? So two important objects those we need to consider are the user and the movies. So profile vector is actually storing the information of the users. So a particular user U1, right? And this user U1, so we are having all the movies. So this user U1 has liked movie say M1 or not, or disliked the movie M1 or not, something like that. If user has given the rating to the movie, then what is the rating for movie 1, movie 2, movie 3 and so on. So such kind of a data for every user is being stored, and this vector is known as profile vector. In item vector, the information related to movies is stored. So if I am having movie 1, 2, 3 up to movie N, then there are associated n number of vectors with respect to every movie. And this item vector contains the details like the cast or the actors those are performing in the movie, who is the director, who is the producer, and something like that, right? So details related to every movie are stored in the item vector, right? Now once we have these two vectors, those describe actually the user behavior and the movie data or the details about the movie, then we need to find out the similarity between two vectors, profile vector and the item vector. And typically the similarity measure that is being used is the cosine similarity. So cosine of the angle between two vectors is computed, right? And formula for computing this cosine similarity between the vectors is similarity between vector A and B, which is the cosine of the angle theta between two vectors. And how to compute this angle between two vectors? We are having this formula. So this is a dot product A dot B divided by norm of A into norm of B. So with this formula, it is possible to compute the cosine of the angle between these two vectors A and B, right? And typically the value of this ranges between -1 and +1, right? What next? Once this similarity is being computed, the movies are arranged in descending order, and one of the two approaches is being used for recommendation. So based on similarity, the movies are arranged in descending order, and if we go with the first approach, that top n approach, then top n movies will be recommended to the user, where this value of n can be decided by the respective business, whoever are using this particular approach. So I may suggest top 5 movies, I may suggest top 10 movies or something like that, right? So the movies are arranged in descending order of the similarity between the two vectors, and then top n movies are being recommended. Or in other approach, the rating scale is being used. So where some threshold is being set by the business or the use case, and all the movies above that threshold are being recommended. Right? So this is how actually the content-based filtering works. So to implement this content-based filtering, we need to know the behavior of the user, how the user has interacted with several items in the data set, what are the likes and dislikes of the user, what are the ratings provided by the user. all that information we need to have. Also, we need to have the information about the movies or the items, right? And based on that information, this content-based filtering actually recommends the user about the new items, right? Is that clear? Yes. Is
Yes,
that
ma'am.
clear? Fine. So let us proceed with the pros and cons or advantages and disadvantages of content-based filtering. So the advantage of content-based filtering is the model doesn't need any data about other users. So as I stated, content-based filtering actually uses the data of the individual user, and according to that, it suggests or it recommends the items or the products, right? So the advantage is the model doesn't need any data about other users, as the recommendations are specific to the particular user. And this makes the approach easier to scale to large number of users, right? So this is user specific, and only that particular data of that particular user is being used, right? So the same approach can be extended to n number of users, and it would be easier to scale to large number of users, right? So that is the very first advantage of content based filtering. Secondly, the model can capture the specific interests of a user and can recommend very specific items that very few other users are interested in. So specific trends of the users can be captured by this content-based filtering method, right? And this is very user specific. Sometimes this becomes advantageous, right? Now, what about the disadvantages? In content-based filtering, usually the features are hand engineered. What we mean by that? Whatever are the features, those we are making use of to describe the user or to describe the item, these features are hand engineered, means these features are described by the person, right, who is building the algorithm for a particular use case, right? And this technique requires, as the features are hand engineered, then we should know what are the important features those we should have, or what are the important attributes those we need to consider. So this technique requires lots of domain knowledge for which we are preparing the algorithm, right? So if the features are hand engineered and if the features are good enough, then only this kind of content-based filtering algorithms will work well. Okay? The model can only make recommendations based on existing interests of the users. Based on existing interests of the user. What does this mean? This means that there are certain limitations to the content-based filtering algorithms. So these algorithms are limited to recommending the items that are of same type. Like if the person has watched the movies, action movies in the past. Say for example, if the user has watched the action movies in the past, then the content-based filtering will only recommend the action-based movies to the user, because in the past the user has not watched any other kind of movie than action movie. Right? So if the user has watched or liked only the action movies in the past, the system will recommend only action movies. So it is a very, what you can say, it is a very narrow way of building the recommendation engine. Or in other words, the model has limited ability to expand on the user's existing interests. Right? It may not possible to explore some other interests of the users for which the user has not responded in the past. Right? So to improve upon this, we need to go for some other algorithms that can recommend the items not just based on the content, but the behavior of users, other users as well. Right? Similar kinds of other users as well. And here is the need for going for the collaborative filtering. Right? So, as I stated earlier, collaborative filtering considers not only a single user, but it also considers the similar kinds of other users. And the recommendation is a collaborative work based on the behavior of the similar kinds of users. Right? So this is one of the popular techniques used by the recommender systems. And these collaborative filtering models are based on the assumption that people like things similar to other things they like, and the things that are liked by other people with similar taste. I'll repeat, in collaborative filtering, the assumption is that people like the things similar to other things they like, and also the things that are liked by other people with similar taste. What does this mean? Under collaborative filtering, we are having two different methods or two different approaches, memory based and model based. So under memory based, I'll be having the user item filtering and item filtering. So let me elaborate what these two types of methods under collaborative filtering. I'm simply introducing these methods. They are not going into the details, right? So in user item filtering, see this picture. In user item filtering, this is one user and this is another user, right? So this particular user is buying this particular item 1 and this particular item 2. This another user is also buying this item 1, this item 2, and also buys this item 3. Right? So, as these two users are having these two common choices, we may say that these two users are similar users. Right? Now, if these two users are similar users, then other than these two items, suppose this is user 1 and this is user 2. So, user 1 has bought two items, I1 and I2. But U2 has bought three items, I1, I2 and I3. And with respect to the buying habits, we may say that user 1 and user 2 are similar users. So, whatever is the third item that was bought by user 2, that will be recommended to user 1. Why? Because these two users are having the similar habits. Right? So, a user item filtering takes a particular user, find users that are similar to that user based on similarity of ratings and recommend items that those similar users liked. So this user has liked or purchased this particular item 3 and we found that user 1 and user 2 are similar. User 1 has not purchased this item 3, but as the similar user has purchased, then this particular item is recommended to this user 1. So such kind of algorithms are known as user item filtering algorithms. Have you understood the concept? Yes? Any doubts so far? User item filtering. Yes? Please pick up. Any doubts so far?
Ma'am, can you please repeat user item filtering?
Yes. See here, we are having various users. Right? Now, to recommend, we want to recommend something to this user, say U1. So how we are going to recommend something to this user U1? First of all, we will be finding out the similar users. So how we are going to find out the similar users? Based on some habits of that user or behavior of that user. So user U1 is having the habit or has purchased item 1 and item 2 in past. The same 2 items are also been purchased by this user 2 in past. Right? Now, as these choices or these buying habits are similar of user 1 and user 2, we say that these 2 users are similar users. U1 and U2 are similar users. Right? Now, we want to recommend something to this user 1. So, how I am going to recommend to user 1? As U2, this user 2 is similar to U1, I will look for the other items. Those are purchased by this user U2. So user U2 has purchased this item I3, which is not purchased by U1. But I have identified that these 2 users are similar. So what I can do is, whichever are the similar users, those I am having, whatever are the items, those are purchased by those similar users, I will recommend those items to this particular user U1. So U2 has purchased item 3. So I will recommend that item 3 to this user U1. And the reason is these 2 users are similar. That I have found out. Correct? Item filtering. So in item filtering, we take an item and we find users who liked or who have purchased that item. And based on the users who liked that item, we find the other items, those are liked by these users or the similar users. Right? See, for example, here we are having 4 items or 4 fruits. We are having orange, strawberry, apple and banana. So if we look at this fruit that is orange, orange is purchased by user 2 and user 1. Right? So user 1 has purchased orange and also user 2 has purchased orange. Now, the user who have purchased orange has also purchased apple. So user 1 has purchased apple. Right? Also, the user who has purchased this orange, that is user 2, this user has also purchased apple. Right? So the user who has purchased orange has also purchased apple in these two cases, user 1 and user 2. Now let us consider this user 3. So user 3 has purchased apple. Now we know that whoever have purchased orange, those have purchased apple also. So two of the users. So what we can do is, or what our system will do is, as user 3 has purchased apple, right, based on the test of these user 1 and user 2 who have purchased apple along with orange, this orange is recommended to user 3. Right? So user 3 will get the recommendation to buy the orange. Right? So this is how the item based filtering works. So in item filtering, we consider an item and we find the users who have purchased or liked that item, and we find other items that those users or similar users have liked or purchased. So it takes the items and outputs other items as recommendations. Right? So whenever user 3 purchases apple, we take this apple and we see who have purchased this apple. Right? So this apple is being purchased by user 2. This apple is being purchased by user 1. So we check what other fruits have purchased by user 1 and user 2 who have purchased this apple. So user 1 has purchased along with apple orange and user 2 has purchased along with apple orange. So whenever user 3 buys this apple, user 3 gets the recommendation to purchase the orange. Right? So thus we may say that in case of user item filtering, we may have the recommendation like users who are similar to you also liked this item. Right? Whereas in item filtering, we may have a recommendation like users who liked this item also liked some other item. Right? So we may say in this case, users who liked apple also liked orange. And that is why whenever user 3 tries to purchase apple, user 3 gets the recommendation to buy orange. Right? So you might have seen similar kind of recommendations on the website like Amazon. So whenever you go for buying something on Amazon, and if you purchase some product or if you like some product, then immediately there are the recommendations based on the item filtering. So if you buy item X, then the system will check who other users have bought this item X. Right? So the system will get the history of those users. So the system will check along with this particular item X, what else these users have bought. So accordingly, these items will be recommended to you. Right? So I hope I'm clear with these concepts. Now, similar to memory-based approaches under collaborative filtering, we are having model-based approaches. We are not going into the details of model-based approaches, but let me brief you about the same, and I would recommend you to go into the details of model-based approaches for collaborative filtering. So these algorithms provide item recommendations by first developing the model of user ratings. So algorithms in this category take a probabilistic approach and they compute the expected value of a user prediction given his or her ratings on other items. The model building process is performed by various machine learning algorithms such as Bayesian network, clustering, and rule-based approaches. As I stated, we are not going into the details of model-based approaches, but I would suggest you to go through these kinds of approaches as well. With this, we are going to conclude our discussion related to recommender systems. Thank you.